everyone. We are diving right into our Math Crush Monday, and we are going to talk about so many methods. So we had a couple questions about this kind of over the course of several weeks. This same idea keeps coming up. And so I thought that we would address all of these different methods and that there's just so many of them, right? So I am going to definitely dive into these multiple methods. And before I do that, though, I just want to give you a little bit of motivation, because if you were like me, you got up this morning maybe a little grumpy and wanting to be on break, right? But as I was taking a very long drive into the schools I was working with today, I kind of had that heart to heart with myself. And I hope I'm going to fix this because it looks like it wanted to leave me. I had this heart to heart with myself about my attitude, because what I know is that I oftentimes complain that I just don't have enough time, right? I don't have enough time with the schools I'm in, with the students I teach, with the teachers I'm working with, that we just need more. We need more exposure, more opportunities to work together, right? I know that the work we're doing is just so critical, and I often complain I don't have enough time. And here I am being given the gift of time to go back into these schools and work with people like you are with your kids. And so my heart to heart with myself this morning was to set my intention before going into the schools, because I needed to show up as the person that these students and teachers needed me to be, right? So I am hopeful that that is the same conversation that you had with yourself this morning, or that you have with yourself tomorrow morning. And so my intention this morning was to set this. I have 3 weeks to make as big of a difference as I can before we all go on break, right? Because we all complain about not having enough time and needing more, and how much more our kids need, that I am hopeful that you are like me and that we are going to make the most out of every minute we have with these kids before we go on break, right? So that we can say we did the most and the best with what we were given. It doesn't mean we're always going to be bright and shiny, but my intention this morning was to show up as the person I know I want to be for other people, so that we make the most out of our time together. So that's my little pep talk for you. I hope that it helps you. I would love for you to just write in the comments that you're here, and to let me know if that motivational Monday speech was just what you needed to hear. So let me know. So tomorrow, my hope for you is that you have that same attitude with your kids. Let's make the most of every moment we have with them. So we talked about this multiple methods idea, right? There are so many methods. In fact, I have this little document here. I'll kind of show it to you a little bit closer, but it has all 4 operations on it: addition, subtraction, multiplication, division, specifically the methods as Math Expressions teaches them. I will post this if you're interested in it as download, and it just shows the different methods that we're going to teach and the visual representations. But the truth is that I really do think that Expressions introduces them very quickly, and in my personal opinion, it is too quick. So if you're feeling that way, like we barely got a hold on the area model and now all of a sudden we're doing partial products or whatever it might be, my suggestion is to go slow, to go fast. I don't think that we need to be the gatekeepers of methods. I don't think we decide when kids are ready or not ready for various methods. So I do want to make sure that kids get access to these methods. It doesn't mean they practice them all, but it does mean they need to have access to them. Okay, so I'm going to slow down a little bit and show you and tell you a little bit more about that. But if I look here, I can see that I have the quantity model. Right? And in fact, I'm going to take them from the most concrete version, that CRA, that concrete, representational, and abstract. And this is that showing all quantities, right? That is the most concrete, the most conceptual for our learners, is for them to see all of the quantities. The most abstract is this new totals above, or new groups above, or you could also say new groups below, right? Those are the most abstract. If you look at down here, you know, that traditional algorithm of borrowing and carrying, okay? If you look at the shortcut method for multiplication, if you look at the digit by digit for division, those are the most abstract. So what I typically find is I find that teachers are starting with these representational models, the most conceptual ones, and then they quickly go to these other methods. But if they get frustrated or they feel like kids aren't getting it, I find that they skip to the most abstract. When in reality, if they're struggling, this should be the last thing I let them go to. Right? So it doesn't mean that I don't introduce it. It doesn't mean that I don't say, oh, what do you see about this? Like maybe post this, right? And next door to the other methods they've done and say, how is it alike? How is it different? What are the similarities? Because they can find that out. They can see, well, they both have the same add-ins. They both make a new group of 10. And this one, it makes a new group of 100. But in this one, it actually puts that new group of 100 in that place value. They can see the similarities and differences and see how all of these are accomplishing same goal. But I know as a teacher, I'm going to probably have them practice the one that maintains the most place value and the most conceptual understanding. Okay, so when I look at this, I'm asking myself, what is this strategy that is helping kids to maintain place value and to build their number sense? Okay, that's where I want kids to really hone in on and to have a lot of practice. As they get that, I'm going to introduce these other methods, and we might just do a compare, contrast, what's similar, what's different, but I may not have them practice that method until they have a really good grasp on the quantity model, and in this case, the show all totals, right? When they really get that, they can explain it, they can draw it, then I might have them start practicing one of these others, but the quantity model never gets dropped. I know this proof drawing always stays, because remember, it's about building solid place value. Your kids are going to want to go to these other methods and drop the proof drawing. It's frustrating for them, but they must have this. Okay, so really what I want you to remember is that with all of these different algorithms and operations, that I want kids to really build deep number sense. And I have a calculator, or they have a calculator for the rest of their life, right? So they will have one of these in their pocket. So I know when I think about long division, I've been talking to a lot of fourth grade teachers lately, right? And they want them to get this digit by digit. And I'm like, but why? It's not necessary. The standards don't even say they have to have this most sophisticated method, as long as the method they're using is efficient and effective. And for a lot of kids, it can be one of these two methods. And the benefit of that is it maintains place value. It maintains number sense. They know why they're putting those numbers there, versus this is abstract. We start dropping zeros. We start putting arrows to carry down. We don't even know what it means. Our kids don't really know what it means, right? So I want to avoid that, because the reality is they have a calculator to do this long term. My job as a teacher is to make sure that they are developing strong number sense. Right. In addition to that, of course, they're going to build these algorithms. I want them to have fluency with these algorithms, but I don't want it at all costs. So I guess my advice to you is this: start with the most conceptual, concrete. Start with that quantity drawing. So I did it here on my whiteboard, and I have, right, this would be the order that I go in. Oh, you can see my light there. That's fine. This would be the order I go in. So here's my quantity drawing, right? This shows all the quantities. I showed two different ways to do that. Make a new group of 10. So we make a new group right here by circling the ones that make a 10, but we also can do it in a 10 stick. Some teachers like that method more. Expressions teaches it both ways. I think it's up to kids how they want to show it, and I'll just let them do their method. So they can make that new group however they want. But this tells me we understand quantity, that we understand that this is not a 2 and a 4, that this is 2 10s and 4 10s. And that's important. Then I think the next one goes to expanded method. That's when we use the secret code cards, but we don't drop the quantity drawing. So the drawing still stays here. In fact, Dr. Fuson would say, if you do it in the drawing, you do it over here in the algorithm. But the expanded helps us to see what the values of those numbers really are. Well, now I keep progressing. As kids really get this along with the proof drawing, then I can say, well, I wonder if we can make another shortcut and we can go to show all totals. So in this one, notice that we're not putting 20 plus 3. We're just knowing now that this is a 20 plus a 40, and that equals a 60. So do you see how each one of these goes a little bit more abstract, but it really relies on the one before to understand quantity? So if I don't really understand this one, I might show kids how this is the same, but I want them to be able to explain how it's the same and different, but they may not be ready to practice this one. They may need to stay here. So even though their workbook is saying practice this one, I know that those kids need to practice this. Okay, when I get to show all totals, then I'd rather just have them stay here. Second grade standard doesn't even say they have to have a standard algorithm, right? So we're introducing it in expressions, but they don't even have to use it. So I really need to make sure that they maintain place value, just reasonability. I see way too many second graders that aren't thinking reasonably about these numbers and thinking about how much would that be? Will I make a new group of 10? They just go straight to adding the right and the left-hand columns without really knowing what they have. So for example, 25 plus, let's just go 25 plus 5. Well, if you see 25 plus 5, you should just be thinking reasonably. That's 30. But I'm seeing kids stack them. Okay, when I go straight to stacking, that means I'm not thinking about numbers and what they really represent. So I always present the numbers horizontally for that very reason, because I want first kids just to see them and to set up in their mind like what they know about those numbers, what would be reasonable. Do I need to stack these and do an algorithm because it's more efficient than me trying to add that or to skip count in my head? Okay, that's why I go to algorithms, because the numbers are going to get too big. So it's going to be generalizable. We want strategies that are generalizable to bigger numbers, right? And so that's why we're going to go through this progression, because we want them to be able to use them when they get to those bigger numbers. So expanded form gets harder to generalize. So it's a stepping stone, but really we want to keep them at some of these other methods, specifically this one is set in second grade and in first grade, because they can use that with as big of numbers as they have, and they'll never ever have to carry anything. So they'll still make new groups, but they don't ever have to carry it. Okay, so that's really helpful for so many kids. It goes from the left to the right on purpose. We read from the left to the right, and we're trying to show kids it doesn't matter. You can start from the right or the left. Why does it matter? Right? As long as we understand what we're doing. A lot of special ed teachers really love this one because it's hard for their kids to transition from reading from left to right to doing math from right to left. Okay, so either way, I'm going to make a YouTube video about this. I owe it. Someone else asked about it, and I intended to put it up, and I didn't get it done. So I will try to do a YouTube video just really detailing how each one of these work and how the proof drawing works with it. But maintaining place value is the most important thing, having deep, good number sense. And I sacrifice that when I let kids jump to an algorithm and they don't really understand it. If they say I carried a 1, I know I'm sacrificing number sense. It's not a 1, it's a 10, right? Now, if they say it's a 1, oh, but I know it's a 10, okay, I can let that go. But the proof drawing, I never, right? They have to have that go for them all the way through second grade. I really prefer they use it in the 3rd, 4th, and 5th grade, or at least compromise every other one, every 3, whatever, because remember, we're building number sense. They will have a calculator to do the rest of this work. Okay, so a couple of reminders for you, CRA, right? So remember, that's concrete, representational, and abstract. We don't necessarily have to make it linear. It doesn't mean you have to pass the concrete stage before you go to representational. It does mean it's kind of circular. So that's why when I'm introducing the quantity drawing, I'm always relating it to something that's more abstract so that we make the connection that this is the same thing. Okay. I also want to remind you, if you're in the younger grades, the daily routines, that we're showing this all the time. So we're showing on the number path how to make a new group. We're showing on the 120 chart how to make a new group of 10. And so I really recommend you do those daily routines. And then of course that mental math of just having some number talks, posting this equation and just talking through how you might solve it, methods you're aware of, what's reasonable, how you might do it in your head. That's producing really good mathematicians. And then of course we introduce some of these algorithms. So long term, to answer that question, I just want you to slow down a little, right? So I want you to, if you feel like your kids are still working on, you just heard my son, they're screaming, they must be fighting in the back room. The quantity drawing, if their kids are struggling with the quantity drawing and expanded, slow it down. They have to understand this before I start introducing these. But it doesn't mean I'm the gatekeeper and I never show them this. Right? They need to see it and they might be able to use it to compare it, but they're not practicing it. So my upper grade teachers specifically, be really careful about, well, but long term, they just need digit by digit. So just teach them the algorithm. They actually don't really need that. And these can be just as efficient and effective. Right? So I would say rectangle section starts to get more complicated as we get to bigger double-digit numbers, but expanded notation can always be used. So just be careful about how quickly you introduce those, or if we let go, because, well, if they're confusing to me, they must be confusing to my kids. Be careful about that. Remember, you've learned it a traditional way. You're unlearning it to teach it to your kids. Your kids aren't necessarily having to unlearn. So what's complicated for you or confusing won't necessarily be confusing for them. So as you get through here and you are looking at the different algorithms and you struggle with one or you don't really understand it yourself, would you just post that in the group? Because guaranteed there's other people that are in the same boat. I would be happy to teach it to you either on a Facebook Live or I'll make you a YouTube video. So hopefully as I get that YouTube video up, you can give it to your parents too to help them see what we're doing. But I think that's an important conversation with parents, is that we're really developing mathematicians, not calculators. And calculators can do all this work, right? A mathematician can explain it, can draw it, can reason. Those are the things a calculator can't do, and that's my job with my kids, right? So I hope that helps. Everyone else, please let me know if this was helpful or not. But my friends, I hope that you make the most out of every minute this week as best as you possibly can with a smile on your face, because those little friends need you. We will talk to you soon. Thanks, guys.